All right, here is lesson 32.4, where we're going to focus on solving quadratics with the quadratic formula. And then we are going to be able to use a part of the quadratic formula, which is called our discriminant, to determine whether or not our quadratic function will have two real solutions, one real solution, or no real solutions. So we're going to skip down to the second page of this lesson. Just a quick reminder that my quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So, reading this paragraph, it says the expression it says the expression square root of b squared minus 4ac in the quadratic formula helps us understand the nature of the quadratic formula. So, what it's talking about is this part of my quadratic formula. Part of that is called the discriminant, and that's what's underneath our radical sign, which is the b squared minus 4ac. And the discriminant gives us information about the number of real solutions as well as the number of x-intercepts of the related quadratic function. Remember that solutions to our quadratic functions, real solutions to our quadratic functions are our x-intercepts. They're when y equals 0, which is why we set it equal to y. Set our equations equal to 0. So it says solve each equation using the appropriate solution method and then complete the rest of the table. So first thing that we're going to do is we are going to write down what the discriminant is. Well, the discriminant, reminder, is b squared minus 4ac. And so we're going to determine if there's a pattern between what our discriminant is and how many solutions our quadratic has. So our discriminant for the first one would be 2 squared minus 4 times 1 times negative 8. 2 squared is 4. 4 times 1 is 4. 4 times negative 8 is negative 32. So our discriminant is 36. Let's determine our solution. So just using the quadratic formula, we already know what the square root, or we know what b squared minus 4ac is. So really we're just dealing with negative b, so negative 2. Oops, I'm going to use a different pen. Negative 2 plus or minus the square root of our discriminant, which is 36, all over 2 times a, which is 2. So we get negative 2 plus the square root of 36, which is 6, divided by 2, which would then be 2. And then we have negative 2 minus 6 over the square root, or over 2, so that would be negative 4. So our solutions are 2 and negative 4. So we have two real solutions, meaning we have two x-intercepts that occur at 2 and negative 4. Let's do another one. So now try to think of your pattern. I had a discriminant of 2 or of 36, and I have two solutions. Let's see what our trend continues with. Oops, gotta go up to the scrolling. Hopefully it will. Perfect. Let's erase stuff that's in this box from my handwriting. Let's do the same thing down here. So first let's do my discriminant. So b squared, so 2 squared minus 4 times a times c. So we get 4 minus 4 times 1 is 4. So 4 minus 4. So our discriminant is 0. So that means in my solution I get negative b. So using a different pen. So negative 2 plus or minus the square root of our discriminant, which is 0, divided by 2. Well, the square root of 0 is 0, so really we get negative 2 divided by 2 for both those, which is equal to negative 1. So really we only have one solution when x is negative 1. So that means we only have one x-intercept, and that occurs at negative 1. So we had a positive discriminant of 36, and we had two real solutions and two x-intercepts. We had a discriminant of 0, and we had one solution, one x-intercept. Let's see what this pattern continues to be. So solving the next one, first finding my discriminant. So we get negative b. Nope, that's my quadratic. So b squared, so 2 squared minus 4 times a times c. So we get 4 minus 20. So we get negative 16. Let's solve that. So, negative b, so negative 2, plus or minus the square root of our discriminant, which is negative 16. All of that over 2a, which is 2. Well, I can't square root a negative, so there are no real solutions. So that means that the number of real solutions would be 0. It means we have no x-intercepts. So let's try to look at this pattern. And see if I can zoom out and have it all be in the same correct boxes. I don't know if that's going to work. No, it didn't work. Not really. So, trying to zoom. We had a positive discriminant of 36, and so we had 2 real solutions. We had a discriminant of 0 and 1 real solution. And then trying to zoom. Our last one, it's not working very well. We had a negative discriminant, which meant we had no real solution. So let's generalize those patterns. So I'm just going to actually clear the selection and just scroll. So it says complete each statement below using the information from item 3. So if our discriminant, which is b squared minus 4a squared, is greater than 0, that means we have 2 real solutions. And the graph of the related function has 2 x-intercepts. If our discriminant, so b squared minus 4ac equals 0, well, we had 1 real solution, and the graph has 1 real x-intercept. And if our discriminant was less than 0, so b squared minus 4ac was less than 0, that means we would have been taking the square root of a negative, which would be 0 real solutions, and that would mean that the graph would have 0 x-intercepts. Let me know if you have any questions. We'll continue to work on this in class. Oops, sorry.